Okay, so today we are talking about natural selection. This is your lesson for today. It's going to be a short one because I don't have a lot of time. So yesterday you should have read about and watched this video about non-random mating and genetic drift, and then natural selection was one of the agents of evolutionary change. But there are actually different forms of natural selection. We can kind of graph them here. So you see there's the original population, and that's the new population, and that's the distribution of traits or the distribution of alleles. So normally what we've been talking about natural selection is we say, okay, there's a pressure, an environmental pressure, and a certain trait is favored, and then things change in that direction of that trait, right? In the direction of that allele. So let's talk about beetles again. I love my beetles. So you got green beetles, you got some brown beetles, right? There's a mutation that makes some brown beetles. They're crawling around on a tree. They're having fun, all of them. But all of a sudden there's a new predator, and the new predator starts eating let's say the brown beetles. So the green beetles are more successful. So natural selection is pushing towards the green beetles, right? So that kind of natural selection is actually called directional selection. So here you've got the distribution, and we're pushing towards green beetle. Let's say over here is brown beetles, over here is green beetles, but because this bird is eating them, the new population is more green beetle, okay? So that's called directional selection. That's the one that we've been talking about the most. But there's other kinds. So there's stabilizing selection. Stabilizing selection is it takes basically the mean is selected for, the most boring, the non. So let's say you have a distribution of beetles, and well, let's just go with size, for example. So there's really small beetles, really large beetles, and everything in between. New predator comes along, and the large beetles move too slow. So the new predator, let's say that's a bird or whatever, is able to catch them because they're just moving too slow, and it pecks at their head and kills them. The small beetles, they move quickly, but the predator is able to, with its beak, it's able to really to get them. Because they're so small, they're really easy to kill. They're really easy to eat just in one gulp. But the medium-sized beetles, they're a little bit big. They're still really fast, so they're harder to catch, and they can't be eaten in one gulp. They've got like a thick shell, so they are able to escape more often than the large beetles and the small beetles. So now we're selecting, if we look at the distribution, so here's small beetles and here's large beetles and everything in between, because the large beetles are being eaten and the small beetles are being eaten, you're selecting for the mean, the sort of medium-sized beetles, stabilizing selection. That's what this is called. And so you're basically taking away the extremes. Another example could be color. Let's say you've got butterflies that are really bright yellow on one side and really bright blue on the other, and then in the middle are sort of like browny, bluey butterflies. And the browny, bluey ones are harder to see for a new predator or for whatever. Yeah, let's just say a new predator. There could be other things, other selections, obviously. But anyways, so the yellow ones are being eaten, the blue ones are being eaten, but the bluey brown ones are able to hide amongst flowers better. They're just, the pattern is hard for the predator to see. And so you're selecting again. Yellow ones, blue ones are being eaten. Bluey yellow ones are surviving. So the next generation, you're getting this stabilizing selection, okay? Now, that's one. And then this is directional selection, which we talked about. And then there's disruptive selection. And disruptive selection, so let's use our butterflies again. So you've got the dotted line is the original population. So you've got yellow ones, and you've got blue ones, and you've got yellowy blue ones in the center. You've got the most yellowy blue ones. But what happens is a predator comes along, and actually the yellow ones are able to hide on yellow flowers. The blue ones are able to hide on blue flowers. But the yellowy blue ones, they can't, when they hide on a yellow flower, though the blue parts you can see. And when they hide on a blue flower, the yellow parts you could see. So the predator is eating the yellowy blue ones. It's eating the mean ones. So what you're getting for the subsequent generations is you're getting more of the extremes. You're getting more of the yellow ones and more of the blue ones. Size could be another one. So if we use our beetle example again, well, this time the predator comes along and the large beetles are too big. It can't kill the large beetles, even though they're super slow. They've got a big, thick, large shell, so the predator can't get at them, so it leaves them alone. The small beetles are super fast, so the predator can't get the small ones. The medium-sized beetle this time, they're slow enough where it can catch them, and their shell isn't tough enough where this predator can eat them. So we're selecting against the mean. So we're selecting for large beetles and for small beetles in disruptive selection. And over time, you're just going to have more and more large and small beetles. And it might happen that the large beetles become really large, the small beetles become really small, and maybe they turn into different species. You might speciate because they can no longer reproduce together because these guys are too big and these guys are too small. Their parts don't fit. That's a form of speciation. Okay, so this lesson, it's a little bit short one. This is also on the assignment. That's why I'm focusing on it. Hope you guys are doing well out there. Hope you guys are watching these videos. I can see who is. So make sure you are. Make sure you're checking in for attendance. Giving me that thumbs up because I'm going to go back and I have to enter it into my head, I think. Well, no, I'm pretty sure I do. Anyways, that's how I'm checking for attendance. So make sure you're doing all of that. You're not just out there hooliganing it out in the world. Okay, bye.